Okay, so this part of our tutorial we'll introduce the last two types, and those are going to be characters and strings. So what we're going to do is we're going to discuss the difference between strings and characters because they're not so different, but there is one main difference being the length. Okay, so characters are only 1 unit in length, whereas strings can be many. So we'll look at the two and we're going to see where we would use them in code, and we're going to take a look at some examples as well. Right, so in this part of the tutorial we're going to talk about characters, and we're also going to talk about strings. So I'm combining these into one video because I think it's good to compare and contrast the two. So what I mean by the two is characters are only 1 unit in length but can contain numbers, letters or symbols, whereas strings can contain numbers, letters or symbols, but can be many characters in length. And you can almost think about strings as being lists of characters. I'll show you what I mean by that. So let's say let's create some variables. Let's just call this variable A, and it's going to be of type character. So as you can see, there's a list of different functions and stuff that come up. We want the first one, which is just type character, and we're going to assign this the value of A. Okay, so characters and strings both go inside the double quotations here. I know in some languages characters are just inside single quotations, whereas strings are in double. However, in Swift 3, they're both inside the double quotations. The difference being that if we try to do this, then this is not allowed. Okay, and the reason being that because this is 2 units in length, the compiler automatically assumes it's a string as it's no longer 1 unit in length, and so we get this issue here that it's saying we cannot convert type string to character. Okay, so that's what the problem is there. However, if we just decrease that by 1, we're fine. We can also, as I was saying before, include numbers. That's fine too. Or we can include symbols. So there's a $, and that's okay as well. So in fact, I'm going to give that the 1. I'm going to create another one, C. It's going to be character, and I'm going to give this a value of the $. And if you want, we can even use emojis. So let's do D. We'll call this character. And again, as long as it's between these two quotation marks, then we go edit, emojis and symbols, and we could just pick one of these. So, let's just pick some random one like this top hat here, for example. And that's fine to be a character as well because it's only 1 in length, okay? So we can also include emojis in the character types. And that's a cool thing about one of the cool things about Swift that you can't necessarily do in a lot of other languages. So keep that in mind. Now let's take a look at strings. So let's have a variable, we'll just call this string1 as this type string. And so when we start to type in string, there are other options that come up. We're just going to pick string here. And let's give it some value. Let's call it mammoth. Okay. Now, the difference between these two doesn't seem like a lot, but the string can contain this. In this case, the string contains 7 characters, whereas a character can only contain 1. If we tried to again change this to type character, then we get this issue that it's too long. So the compiler thinks it's a string because it's several units long, whereas if we change that to a string, we are okay. Alright, so basically you can go from a character to a string, but you can't go from a string to a character. So if we change any one of these types, it would be fine. So this is fine to be a string or a character. It's just that a character has to be only 1 unit in length. So that's the main difference between the two. I'll show you something cool that we can do with strings. So if we have a string 2, and we'll say string, and this is equal to interactive with a space. And then what we can do is we can combine these. So we go string1 plus string2. And it will take string2 and stick it right onto the end of string1. And this is called appending. Okay, so if I just expand this window up a little bit so that we can see the full results, we get Mammoth as a first string, the space interactive as a second string, and then we get Mammoth interactive printed out as 1 because we combine the strings. Now what we can do is, rather than just using the plus operator, is we can do the string1 plus equals string2. And this operator is basically doing the same thing as this line here. So string1 equals string1 plus string2. Okay, so these two lines of code, this one here and this one here, are doing exactly the same thing. So this is just saying string1 equals string1 plus string2, just in short form. Okay, and that is a very useful trick because it saves a lot of time if you're having to do this a lot. Now the difference here is that string1 now contains a value Mammoth interactive, whereas on this line string1 was still Mammoth. Okay, so I'll show you. Here's string1. See, so it just contained Mammoth down there, but because we did the plus equals, we're saying string1 is the old value of string1 plus string2. Okay, so that's that, and that's something cool you can do with strings. So basically you can think of strings as just kind of an array or a list of characters. And in fact, in languages such as C, there is no string. You have to use just lists of characters. And so that's just kind of one way to think of it. Now strings are particularly useful for displaying messages or text within the code. So if we scroll up to the top, we have this string that's automatically initialized to be hello playground. Well, generally if we want to print something out, very often print statements will take in only strings, and basically so anything we put in there we'd have to convert to type string. Now we can perform a conversion between certain strings and characters to stuff like integers. For example, let's take a look at character B. So it contains a 1. Alright, that's a number, but because it's between these quotation marks, it's interpreted as a character and not a number. Okay, and basically anything between these quotations is actually considered to be a string by the compiler, but in this case we've explicitly told the compiler that they're characters. Okay, so unless we state that they're characters, the compiler interprets these as strings. We can also have empty strings, by the way. So if we have string 3 and type string, that's fine. So this just basically contains an empty string, whereas if this was a character, that is not allowed. We get this error that it cannot convert to type string, because anything in these quotation marks is considered to be a string unless we say it's of type character, but because this doesn't actually contain anything, then the compiler thinks it's a string. So just keep that in mind, that we can have blank strings but not blank characters. Okay, so let's get back to that idea of conversion. So let's say we want to convert this character into an integer. So we have the int, and we'll feed in character B, and kind of invoke initializer of type int with an argument of type character. However, if this was a string, so if we created another string, so let's say string, we can call this string to int, so type string, and we'll give it some kind of value such as, we'll give it 2. Okay, so and we'll feed in string to int, then this is fine. Okay, so we can't convert characters from, or rather we can't convert characters to integers, but we can convert strings to integers provided that it has a numerical value inside. However, if we did something like this, let's say hello, then this contains a value nil, and that's because hello doesn't contain any numerical values. Okay, so we can't represent either an H, an E, an L, or an O in number form. So that's why we get the nil value here. Alright, however, if it was a number, 12, then that's fine. It can contain the value 12. And we can also go the other way as well. So if we have an integer, let's say we have a variable sum int, and it's of type integer, and we give it the value 56, then we can go string, and we'll give some int, and that's fine to do. It just takes the integer value and converts it to a string. Okay, so it's no longer represented as a number, it's considered to be a string. So those are some pretty cool things you can do conversing back and forth. Now, where you'd actually see strings and characters in real life is basically anytime you want to represent a number, a symbol, or a letter, and you don't want it to be, for example, you can't call this A because otherwise the compiler thinks it's some sort of a variable. Whereas if you put this 1, the compiler thinks that it's an integer. And same with the symbol, the compiler doesn't even recognize this symbol, it gets all confused. So that's where you might use characters. If you want to basically store a one unit character without the compiler interpreting it as something else. Strings are useful for messages or text within the code. So like I was saying earlier, some print functions only take in strings. Stuff like if you're building apps and you want to change the text fields of certain widgets within an app, those are generally strings. So strings are generally used when we're dealing with messages or text within the code. Okay? So in this case we had some strings such as Mammoth Interactive. These are names, so that's a good place you'd use strings as well. Okay, and otherwise that just about sums up strings and characters. So let's just do a little recap. So characters can contain letters, numbers, or symbols, or even emojis in this case, and are between these two quotation marks, but they have to be only 1 unit in length, otherwise a compiler thinks they're strings and gets an error. Strings are anything between these quotation marks that we haven't explicitly casted as type character, and can be many units in length, or can even be empty, so have a length of 0. Okay, so there isn't a limit to the length of strings. Now we can add strings, and it basically just takes the second string and puts it right on the end of the first. And we can even do this plus equals, which reassigns a string to be its old value plus a new value. And we can also convert strings to integers. As we've seen here, we can manage to convert 12 to an integer, and only if it contains a numerical value though. And we can also go the other way. We can convert integers to strings, no problem. So these are some of the cool things you can do with strings, and remember, good for messages, good for text within the code. Okay, so that just about sums up strings, and we'll be looking at some more complicated stuff we can do with variables right after this. Okay, so this was our intro to characters and strings. So just to recap, characters are basically just strings that are only 1 unit long, whereas strings can be from 0 to basically an infinite length, and they can contain pretty much any type of characters. And so can characters, so we can have letters, numbers, symbols, or even emojis that we saw in either characters or strings. It's just that characters have to be only 1 unit in length, and the compiler automatically defaults anything within the double quotations to a string unless we call it to be type character. We saw that we can also perform some operations with strings, such as appending one string to another, and we can also convert strings to integers, providing that the string is just numbers, and we can also convert numbers to strings. Okay, so we can do some pretty cool stuff with these. They're very useful for displaying text and there are a lot of fields that only input strings, such as when you're designing apps, any kind of like label text, any kind of text fields, they're all strings, okay? So keep that in mind if you do get to app development.